All right, so in 3.1, we're going to look at just simply equations with two variables now. Okay, open sentences or equations with two variables. So in this case, instead of solving single variable equations, now we have x and y, or a and b, or c and d. It doesn't matter, right? X and y is just a traditional way to write out variables when we have two variables, but it does not make a difference. You're going to learn in a year or two in physics that you kind of don't even use x and y anymore. You start using so many other variables for different things where you apply to science. Okay, but for simple math stuff, we're going to see x and y a lot. We're going to talk about solutions to open sentences, and then we're going to talk about ordered pairs with word problems. Let's first start, okay, an open sentence that has two different variables is said to have a solution that is a pair of numbers. A pair of numbers. Since we have two variables in the open sentence, then there are two values that are needed. The question is figuring out what those values are. And what we're going to see is that that's where a line comes from. Okay, we're going to see in this chapter linear functions, and that's what your project for the first quarter is going to be on. Okay, that first quarter project, you're going to be able to actually start doing it soon once we go over this section, these next few sections here. But we're going to see that a line is really a bunch of ordered pairs put together, connected. Okay, and those ordered pairs are solutions to an equation. First one, five different solutions for this. Well, why did I put 5? Because you could find as many as you want. You could find an infinite amount of solutions to this equation here. How come that's true? Why can I find an infinite amount of solutions here? Inigo?
Because you have two variables.
You have two variables. So, Inigo, what's x in this equation?
Whatever you want.
Exactly. Whatever you want it to be. And whatever x is, that gives you, as a result, the y value. So if x is 2, then you might get a different y value. When x is 7, you get another y value. When x is 20, you get another y value. So you could sit here all day and try values for x, right? And you get a different value for y every time you plug in a value for x, assuming it's a function, which we'll talk about in this chapter. So as a result, these kinds of questions, they're an infinite amount of solutions. And a line is an infinite amount of points, right? How do you make a line? When people say, like when Miss Coop is yelling at you in the gym or going to matches, make a line, what do? You stand up one after the other, right? So if Sarah's standing here, and I'm here, and Emily's here, and Christian's there, well, we're all points on the line, aren't we? And we make up a line, really. So technically speaking, a line, again, extends in both directions, infinitely. So there are infinite solutions to this. So go ahead and pick 5 values for x. This is not specifically giving you a domain, so you don't have to choose certain values of x. Pick any values of x. Usually you make a table for something like this, or you make ordered pairs to help you. It doesn't matter, okay, but just to organize yourself. And literally pick values for x. I'm going to pick random values. If you want, you could go with the traditional -2, -1, 0, 1, 2, which you hear a lot of because it hones in on the origin. So you could choose those for x if you want to. Or maybe go -4, -2, 0, 2, and 4. But usually if you're picking some values that will help you, maybe you pick some that are symmetric. -4 and +4, -2 and +2. But it really doesn't matter at this point. Now, before you go and figure out all the y values, what should you do? I don't want to go ahead and plug in x 5 times and have to solve this equation 5 times, do I? Isn't that a mess? Solving this equation 5 times? So instead, what should I do before I begin this problem? Instead of plugging in the value of x, right? Instead of plugging in a number and solving, plugging in a number and solving 5 times. That's a waste of your time. What should you do? Daniela?
Solve for x in terms of the other variables?
Solve for?
Or for y.
Good. So solve this original equation for y first. Right? Remember, utilize your time properly on a test. If you plug in 5 values of x and solve it 5 times, you are wasting a ton of your time. Okay, you need to go through this problem in some sort of a logical fashion. So to do that, what do? I know we've done this in the first chapter, but refresh my memory. How would I solve this for y? I treat everything else like they're numbers. So think of x as a number. Think of the 4x as a number. What would I do to solve this? Alex?
You leave the y by itself.
Good. So what do I do in my first step?
You subtract 4x.
Remember. Good.
And you divide by 3.
Very good. So remember to think of x as a number when you're not solving for it. Remember, any variable that you're not solving for consider a number. So if x was a number, this would be a number, like, say, 30. Well, you would subtract 30 first. So you're subtracting this quantity 4x, leaving us with 24 minus 4x. There was a 3 in front of the y. To get rid of that 3, we divide. Now, nowhere did I say to you, put this in slope-intercept form, which a lot of you know what that is already. So you don't have to go any further than this. Leave it like that. You don't have to divide through. If you want to, you could write this as 8 minus 4/3 x. That's totally fine if you divide the 3 into both, but you don't have to do it. Okay, but if you want to, because if you like simplifying things, you could write it like this. All right, that's another way to write it. Divide the 3 into both terms and leave it that way. Doesn't matter. So now please take the x values and plug them into the solved generic form for y. Okay, plug them into this equation here to get 5 y values. And depending on which values you chose for x, you might get different answers than what I have up here, unless you chose the same values as I did. Did anybody choose -4 as an x value? What did you get, Inigo, when you put -4?
Oh, I haven't done it.
Oh, you haven't? Okay, sorry. Take a look at your numbers and let me know if you have any of these solved, let me know. Or evaluated, I guess.
Do you want it in decimal?
I'd say fractional form for now. We can give an approximation with the decimal, sure. But give me the fraction first.
I think I got 40 thirds.
Yeah. So the first one, you're going to get 40/3. Oh, that is ugly. Hold on. Let me rewrite that. For this first one here, you're going to get 40/3. Now, as a decimal, we're going to get what? 13 1/3 for that? 13 1/3 should be? So around 13.3. And that's clearly 0.3 repeating. We know that because that's what our thirds are. How about the -2? When you plug in -2, what do you get? Say again? 32/3, which is approximately 10.7 or 10 2/3. 10 2/3 would be 10.6666 repeating. The 0 is the easy one. It's just 24/3. 8. Very good, right? The 0, you literally just cover this up right here. When x is 0, you get 24/3. How about the +2? +2?
16/3.
Good. Which will give us 5 1/3 or 5.3 repeating. Again, I'm rounding to the nearest tenth for a lot of these. And last but not least, plugging in a +4. 24 minus 16 is 8 over. What do you have for this last one? Yeah, 8/3. Okay, approximately 2.7. Now, give me your opinion for those that evaluated this. Method 1, using this equation, or method 2? Which is easier when doing this by hand? Which of these two equations is easier to use when doing it by hand? When you're doing a calculator, obviously, it doesn't matter. If you're doing it by hand, honestly, which way is easier? Think about it. If you plug in a number here, right, everything's in thirds. Do you see that? Plug in a number, you get an answer in thirds. Plug in a number, you get an answer in thirds. Here, though, if you plug in a number, you're going to get an answer in thirds, and then you're going to have to subtract it from 8, which you're going to have to make a common denominator to subtract it from, right, if you're doing it by hand. So in the end, doing this extra step to give us the second equation at the bottom right here really doesn't speed up the process at all. So I would have used the first equation here, because it's already with a common denominator of 3. Whereas here, by dividing 3 by 3, you then have to go back and reverse that and write 8 as 24/3, right? Which really was here anyway. So again, I would have chosen the first equation that we wrote there to use to solve or to evaluate for the y values. Pull your calculators out, please. Calculators out. Go ahead and press Y1, please.
I forgot it today.
Go ahead and press Y1, please. In Y1, if there's something there, clear, please. Clear it out. If there's something there in Y1, just hit clear to clear it out. Go ahead and type in this function right here. Let's use the first one here. So parentheses. 24 over, you need parentheses on your numerator, right? You divide the whole thing by 3. Parentheses 24 minus 4. Now, where is the X key on the calculator? Who can tell me, where is the X key on your graphic calculator? Now, I'll give you a hint, it's not using that alpha command. There's actually an X key on the graphic calculator. Because there's a bunch of letters, right? The whole alphabet's kind of on there. But there's a key that's specific to X. It says like X, T, theta, N. It's got a bunch of symbols on it.
It's like right next to the alpha button.
Yeah, so it would be to the right of the alpha button. Look at the alpha button on your calculator. To the right of that, you're going to see it's like a independent variable. That's what that means, X. So you're going to go ahead and type in parentheses 24 minus 4. Then you're going to press that X, which is to the right of the alpha key. Close your parentheses. So you close your numerator, and then divide by 3. Okay, now press second, and then press graph to bring up the table. Press second, and then hit graph, which will bring up the table. So we all have a table in front of us right now. Even though if you don't, so I'll just come by and make sure you do. Help you out if you need help. Good, good. Got the table in front of you. The table's good. Okay. Now, go ahead and press the button that says, press second and then press window. It's table settings. That's what it really is, the button that you're pressing right now. Make sure you're looking on, by the way, girls. If you don't have yours right now, it's fine. Just look on so you see what's happening. So press second and window. Now, under table setting, see under independent? At the bottom, it says independent and dependent there, and both things are highlighted under auto. Highlight ask for independent, and hit enter on it. Go down to independent, go over to ask, and hit enter, then go back to your table. Press second graph again, and go back to your table. Good. Press second graph again, and go back to your table. You should see an empty table. Does everybody see an empty table completely? Gentlemen in the back, all good, right? Jeff, good? Morgan? Okay. Now, in that table, you can type in numbers. So type in -4, enter. The negative button is on the bottom of the calculator, not the minus sign, make sure, the negative. -4, enter. -2, enter. 0, enter. 2, enter. 4, enter. Now, we have some patterned RX values. So we could have had it on auto and just gone by 2s and done the same thing, right? But this ask feature allows you to literally choose X values to evaluate the Y values corresponding to them. Okay? So just utilize that if you need to. If you want to go back to where the table picks numbers for you, you can just go back to the second window, change the table setting back to auto, and it will automatically fill in X values. But if you need specific X values and you want to sit there and scroll through it all day, right? You don't want to sit there and scroll through the entire list of X values. So maybe you want to choose ask, and then you can ask the calculator some X values and let the calculator calculate the Y values. Questions? The calculator is a tool, right? If you don't know how to use it, it's a worthless tool. I could come in with a hammer, but would a hammer help me to unscrew this door hinge right here? No, it would do nothing for me. It's the wrong tool, right? It wouldn't make any sense. I could sit there and smack with a hammer, it's not going to do anything. It's just going to break it, if anything. The calculator is the same. You will not get the right answers. You will not get the answers you want if you don't know how to use it as a tool. Okay, so you have to use it properly. So make sure that you're ready to do that. Specifically tells you the domain of X. So what does that mean here? And I want you to use your calculator in this one. I don't want you to do it by hand. It tells you the domain of X. What does that mean? Who can tell me? What does the domain indicate, Em?
X can only be in between those numbers.
Yeah, or those numbers, let's say. X can only be these values. So this problem already gives you the X values. So this is very useful to have that ask feature on your calculator now. Because now you don't have to run through all these numbers. You can type it 2, 1, 5, 7. And you can overwrite the table. You can type over the numbers that are already in there. But remember, in your y1, what do you have to put? You have to put this equation in y1, but you need to solve it for y. So I'm going to add 4 to both sides, and then divide by 3. Okay, so go ahead and put this in y1 now, the new equation that we've got here, making certain to put your numerator in parentheses. The numerator, oh, that is so ugly. Why does that not work sometimes? Put the numerator in parentheses here, please, like that. Okay, so y equals, this is in y1, so if you need to get to y1, press your y, the top left button on your calculator. That's fine. So just retype it, parentheses, right? You should have cleared it. Again, clear what's in y1, parentheses, 3x plus 4, close parentheses, divided by 3. And go to your table and type in these 4 numbers for x in your table. And you can overwrite the x values that are in there right now. Whatever you typed in a moment ago, you can just type right over. I'm going to give you the nearest 10th. Because it's again in thirds, right? Looks like these are all going to be thirds. Check your table. If your table doesn't have these numbers, something is wrong. Okay, again, you need to type in the x values, but the y values should come out to be those values you see on the board there. Hey, is it there, right?
Yeah.
Oh, there it goes. I was going to say, it's going to very soon. So listen, tomorrow we're going to review. There's a little bit left in this section. Okay, I give a simple word problem in example 3. This one's easy. Watch that one tonight before you look at the problem. Okay, this will take you like 3 minutes to do. We'll look at example 4 tomorrow. Don't go crazy with example 4. It's a little bit trickier. But example 3, just watch my video and Mr. Howell's videos for example 3 to see that last one. It's a simple word problem, but I want you to practice it. Okay?
So the 3 1 set that's going to be due tomorrow.
So everything is due tomorrow for the problem set, but no homework for 3-1 is due tomorrow. The homework for 3-1 will be due on Wednesday instead, to give you a little more time. Please get those problem sets on so I can give you the answer keys so that you guys can study from them for your test.